Okay, so what I want to do now is just to go to the prescribed textbook and just show you sort of where we are. Okay, so this is now what they show in the textbook in just chapter 1 is sort of an example version. But I just want you to see more or less what's going on here. And what's going on here is essentially there's a residual equation. There's something that we want to try and get equal to LU equals to P, for instance. So there's some version of a residual equation that gets multiplied by a weighting function, yeah, and then it gets set equal to 0. And if we were now to take derivatives with respect to the weighting function unknown variables, we'll get a system of equations that we can solve, linear algebra equations. So this is essentially the weighted residual approach that you can see in action here. But now I've equipped you to really just look at this and say, this is not just faith that if I just multiply this with an arbitrary weighting function and set it equal to 0, that it will work. It's not just a faith argument, but it's sort of now completely understand that we are solving sort of the difference of this, the sum of this error squared, or sum of this difference squared is what we're solving. We don't have to guess or anything or go through hand-wavy arguments of what's going on here. Like if you choose complex W's, this is sufficient to say that it's equal to 0. Now we understand exactly what we are doing. And remember, we always choose this weighting function to have the same shape, same form and same characteristic than as U, and then this Galerkin's method becomes what's called Bubnov-Galerkin method. Okay, and that is essentially where we are. So this is just to give you an idea. The alternative approaches that are used to solve this is sort of minimum potential energy approaches. What I don't like about them is that they require us to think from the one thing that's nice, allows us to think from an energy point of view, but what is not great is there's a bit of faith that if we solve this, then we've actually solved equilibrium. It's not always straightforward and obvious that that's the case, unless you're quite comfortable with variational forms and variational energy methods. The fact of the matter is, this work potential has got also its own little interesting interpretations. But the fact of the matter is, when we do this version, the Galerkin method approach, it's clear that we are trying to get a system of equations equal to 0, and it's clear that we want to try and find something, for instance, equilibrium. And you'll see what we're going to do now is to apply this weighted residual method to the strong form to derive the weak form of the solid mechanics boundary problem. And that's the problem that the finite element method solves. But what you'll see is we'll start off with a residual equation that says this is equilibrium. And then at least we know exactly what we are solving. We don't have to guess. Okay, so this is just to make sure there's a link back to the textbook. You can understand more or less where we are now in the textbook.